Thank you very much, Wayne, for the introduction, and thank you very much, Angular Kenya, for the invitation and for organizing this event. As you said, I will talk about the progressive web app, and also I will show in a couple of demos how we can create progressive web apps with Angular, because indeed we want to talk about Angular. And I will start with just a little introduction, theoretical, and some basic concepts about progressive web apps, so that even people that are not familiar yet with progressive web app can still get up with the pace of the talk, and then also get ready for the more advanced topics that we will cover later on. But that's it for the start. Let's see. Share my screen. You should be able now to see the slides, right?
Yes, yes.
Perfect. Okay, then let's start. Let's see, first of all, a distinction between a progressive app and native apps. This doesn't want to be a fight nor a competition, just some concrete differences between the two technologies, the two solutions. First of all, when we develop a progressive web app, we don't have any app or Play Store dependencies. We can just deploy it and it's available immediately. There are no multiple versions to support. It's at the end just a website, a web app, therefore there is just one version. Typically, progressive web app costs less than a native app. This because on one side, we don't have to buy any further licenses for Android or iOS development, and also because we can reuse the know-how that is already embedded and available in our team. And as a last, also progressive app have a much smaller memory footprint once installed on a user device compared to native apps. Before going further, just a couple of words about me. My name is Francesco Leardini, and I work as a software engineer and Angular trainer for Trivadis. We are a company, a consulting company based in Switzerland, but with several offices mainly in Germany and Switzerland. And I'm originally from Italy, in a small village in front of the Adria Sea, and it's very nice and very lovely, especially in summer. You can have my Twitter handle and the dev.to portal where I usually publish my articles if you are interested in. But let's start now our travel in the progressive web app world. Imagining a common scenario. We are traveling maybe in an area that has not a very good network coverage. Maybe we are in the surroundings of our city, or sometimes just commuting from home to the office. And when we navigate over internet, maybe accessing a website, and we skip from one page to the next, this is often what happens. So just we don't have any internet connection, and this is a very poor user experience that we give our users if we don't implement in a proper way a progressive web app. But again, thanks to progressive web app, nowadays we can provide a much better user experience to our clients, to our users. As a minimum, we can provide a branded offline page, providing colors and eventually some logo of our company. We can even provide some phone numbers or some static data that can still be useful to the user when he or she accesses while offline. Other companies, though, bring this concept even to a next level. For example, Trivago, when we access the website a second time and we don't have an internet connection, Trivago offers us an offline game labyrinth. This is a very interesting and tricky idea because thanks to this, it keeps the user attention on the website. So maybe the user will play with the game, and then as soon as the connectivity, hopefully soon after, will be restored, the user will be redirected to the originally requested page. So that we don't lose with this game, with this idea, we don't lose a potential customer. And this is possible with progressive web apps. Let's see a small test now. Here is a screenshot of my phone where I installed the Progressive Web App from Twitter and the relative native app for Android. If we open the two applications, we can see, if we compare them, we can see that the details are very close, and except some very small icons or colors, the layout is extremely similar. And this is indeed the goal of Progressive Web Apps, to try to provide a user experience that as close as possible to what is the same as a native app. So I let you guess a few seconds which one is a native app and which one is the Progressive Web App. Indeed, it's not so easy. If we see again, it's almost the same. All the elements are really, really similar. To help you, I just give you a little hint that should make or find the solution much easier. On the left side, on my phone, I checked it this morning, that application took 116 megabytes, while on the right side, only 384K. So from these, maybe you can guess which one is the native app and which one is the Progressive Web App. Indeed, if we look again at the layout, we can see that they are really, really similar, almost identical. So now that we covered some of the general concepts of Progressive Web Apps, let's describe the two most important components of Progressive Web Apps. The first one is the service worker. A service worker is just a JavaScript component and is similar to a web worker, but differently from a web worker that doesn't have a specific job, the service worker acts as a proxy between our application and the server, the client application. So it will intercept all the requests, and according to how we implement the caching strategies and the service worker itself, it will eventually provide some assets or some responses from the cache if there is a match with the intercepted request. Let's see how a service worker is installed and how does it work. When we access a website the first time, in the response, we also download the service worker. It's just a file, JavaScript file, get installed on the client side. And then, according to how we implemented the service worker, we can eventually already cache some assets on the client side. Then from that moment on, even if we don't have an internet connection, if we make a request, this will be intercepted by service worker, and hopefully the requested assets are already in the cache. So we can provide this data even without having to access or even without needing an available internet connection. Therefore, our web application is capable of providing data even when the user is offline. So this is how, in a very simple way, how a service worker acts or works once installed on the client side. A second very important and the core component of a Progressive Web Apps is the web manifest. The web manifest is a JSON file that provides a series of properties that instruct the browser, saying how our application should be rendered once installed and then opened on the client side. We provide a name and a short name that will be used under the icon once installed on a user device. Short name will be used if the name string is too long. So we have to keep in mind that to not have a short name that is too long, otherwise that also will be truncated. A very important property is the display property. We can provide different values for that. Browser, and these would open our Progressive Web App as a normal way when with a mobile device through a browser we access a website. So not really interesting. We can see we have all the browser UI element like an address bar, for example. Much more interesting is the standalone as a value. This removes some of the UI elements of the browser and also opens the application in a separate tab. We will see later in the demo what does it mean, but it will make our application look like really a native app and not like a website. Finally, full screen, as the name suggests, takes the whole screen of the device. And this value is most suited for applications that have rich media content or games. We can provide then a start URL for our web app or PWA. And this is very important because we want that our user always starts with the same page, exactly as a native app. We don't want that the user, once opening our PWA, accesses and opens the last visited page. We want always the same initial page. Again, in order to provide a similar experience like a native app. And then we can provide a set of icons. We can, there is no limit how many icons size we can provide. And these icons will be used to have once installed on the user device as an icon, or for the splash screen, that is an icon that is displayed while the application is opened. Of course, only for the browsers that support this. Chrome suggests to have at least 2 icons. One is 192 pixel square, and the other one is 512. Then Chrome, in this case, will be responsible of scaling these icons according to the target device. Of course, if we go to production, we might want to target multiple devices. And because of this, it's much better to have a series much wider of icons in order to provide the best resolution for our target users. Another thing we can see here is the value or the attribute or the property purpose for the icon. Here we can define indeed the purpose of these specific icons, and these, in this case, we can define them maskable icons, and as a fallback is any. At any is the generic value for all icons. But what are, first of all, maskable icons? Let's describe these. Some manufacturers, like Samsung, for example, they want to have a consistent shape for all the icons on their phones. So they started having the icons shaped with rounded edges. After them, other manufacturers decided to have the same, but of course with different icons. Because of this, Android from the version 8, so from Android Oreo, introduced the concept of adaptive icons. So the possibility to add an image with extra spaces around the edges. In this way, then Android can crop these edges in order to render our icon in different shapes according to the target devices, so Samsung, LG, or Pixel, for example. This is good, but this is a problem for progressive web apps that don't provide icons that are so-called maskable. Let's see what this would be. So we can see here icons that are not maskable. So what could be that we have on an Android device, Oreo or later, we have a white background, or some edges might be cropped instead of showing the full background and no cropped edges. But how can we be sure to provide icons that are maskable? To do so, we have to define our icons that have at least 40% of width, that this is considered a safe area. Meaning that everything that is within this 40% of the width of the image, everything that is inside this safe area, we are sure that it will not be cropped, no matter which kind of shape will our image or icon be rendered. Whatever comes outside of this safe area might be eventually cropped. So we should be sure to provide a proper padding in order to be sure to not have anything cropped away. There is a very nice tool. You can see the link in the top right corner. So Maskable App Editor, that allows you very easily to upload some images and then provide a padding in order to be sure that your icon will fit and will fall within this safe area. So with this, then we are sure that even on the latest Android devices, our icons will always look good. These to give an introduction about the core concepts and the core components of progressive web apps. Now let's go a little bit more in the technical perspective and see how we can provide and make our PWA fast. This is possible thanks to caching strategies. Caching strategies are very important because allow us to implement a logic and tell the service worker what and when to cache the requests or the assets. This is because service worker otherwise by default doesn't know anything about what to cache. So we have to instruct the service worker, and we can do that by implementing the cache API and defining specific caching strategies. This, as I said, is very important because studies show how in the past years the mobile web traffic really took over the desktop traffic, and in 2019 even it was more traffic than the desktop devices, and the trend will move and make this gap even more significant in the next years. Therefore, it's really crucial to be able to optimize our web apps for mobile devices. And a very good way is indeed to implement caching strategies, but in a good way. Let's start seeing this, the simplest one, the cache first strategy. This strategy is ideal when we want to build an offline first approach, and also to provide a very fast response. This is because once we execute or we trigger a request, the service worker intercepts such a request and then try to see whether the asset is available in the cache. In the positive case, we provide that asset immediately from the cache. Therefore, the response is extremely fast, almost immediate. Otherwise, if the cache doesn't have this requested value, then we fall back to the network, and then that case would be just a normal network call. But with the cache first strategy, we can already provide the data even when the user doesn't have a reliable or working network connectivity. On the other side, there is the network first strategy. This is exactly the opposite. We want to provide, in this case, the very latest values, the most up to date. And because of this, we go immediately from the network. But we can still provide the data in case the network times out or we don't have a network connection at all, and then provide the requested values from the cache. This kind of strategy is ideal for resources that update frequently. We might think, for example, to a stock exchange website, and in that case, it's very important that we can provide always the very latest shares values. In this case, if the very latest values are crucial for our users, we should be aware that with this strategy, the offline users would benefit or would use data from the cache that might be obsolete according to our domain. So for improving and giving a much more precise information, we should eventually show in our UI that the data that we are showing is not the fresh one, but comes from the cache. But this, of course, all in case it's really crucial that only the very latest date is provided. Aside from these two strategies that are at the moment the only one provided from Angular, we will see later on in the demo the details, there are other caching strategies available. For example, one of these is the stale while revalidate strategy. And this is a kind of a hybrid between the previous two. So allows to have a very fast response because the service worker goes immediately to the cache and tries to provide the data from there, if available, of course. But also, in the meantime, the service worker in the background goes over the network and tries to see whether there is a newer version of the requested assets. And in the case, then it will download and updates the local cached version, so that the next request will go straight to the cache, but we have now a newer version of the requested value. To implement such a strategy, there is some more code to write. It's not very complex, but indeed it's a little bit more complicated compared to the previous two caching strategies. Here, I won't go over the code because indeed it's quite straightforward, but I want to point out about or say some words about the event.waitUntil method at the end of the code lines. This is very important because this method extends the lifetime of the event. If we don't call this method, the service worker could be stopped at any time by the browser. So with this method, we say to the browser to not terminate our service worker until the promise that we pass as a parameter is either resolved or rejected. So it's very important that when we implement these caching strategies, we use this WaitUntil method. And this is also the reason why we should never have a state in our service worker, because it could be that in any moment the browser will just kill if the service worker is in a loop or the need for resources, it might kill the service worker. So we would lose everything. However, luckily for us, we can use some tools that abstract this complexity and let us concentrate on the logic rather than on the caching strategy complexity. One of these tools is called WorkBox and is an open source tool from Google. It consists in a set of libraries and node modules that can make it really very easy to cache assets and HTTP calls. It works by registering routes where we can define string or regular expression to target some assets. In this case, we want to target the JavaScript and the CSS assets. And then we can just invoke one of the multiple methods that are provided by this tool. In this case, all the code lines that we saw just before are here achievable with just one line code. So indeed, we can see that WorkBox allows to abstract the complexity and just to focus on the logic and not on the details and the complexity around the progressive web apps and the service worker. WorkBox is a framework agnostic solution, meaning that we can use it for an Angular application, but also for React, Vue.js, or even vanilla JavaScript. It works with any of these framework. But since we are talking or we are interested in Angular, let's see how it's possible to inject the progressive web app capabilities into an existing Angular project. Since the version 1.6 of Angular CLI, thanks to the add schematics, we can inject in existing Angular project progressive web app capabilities and features with this command. Let's see now in a demo which are the files that are created with this command, and let's see also how easy is with the Angular CLI and the progressive web apps provided by Angular, how easy is to start creating in a matter of really 1 hour maybe or less a first progressive web app. The demo is available at that URL slides, and I will provide in any case on Twitter my slides. So at the end of the slides, you will see my Twitter handle, and you can follow me or just look at my post in order to have all the details about the repo and the slides. So that's it. Let's see our application. So on purpose, I created a brand new application and I executed this ng-add angular PWA command to see indeed how easy it is to start with progressive apps. What this command do is downloading the service worker module folders and register the service worker. This is done in the app module. This file, NGSW, so Angular Service Worker, worker.js, is really the file that implements all the logic of the service worker. And this is taken straight from the app node modules, sorry. So this means that we cannot change this file by hand, because every time we make a new build, Angular will override our edits. So we can, if we want, to extend the default Angular service worker by using inheritance, and so mixing or combining this existing service worker with our custom one, and then registering the parent file instead of this one. But at the moment, Angular is a little bit limited in that sense, so it doesn't come out very easily. We have to add something. Another file that is created for us is the manifest file, the one we saw before. Angular by default provides the Angular logo, and we can see here multiple sizes. The purpose also is a new property that has been introduced since Angular 9, and the maskable is also a new value that has been introduced. So these are just default values that we can, of course, customize according to our project, but otherwise we can leave it as it is. And this is created everything for us. This web manifest then is registered in the index.html. We can see it here. And this is also done automatically for us. Before going further, I would like just to say couple of words about this line. So Apple and iOS in general still don't support completely or so much progressive web apps. And this is really unfortunate. For example, if we wanted to provide an icon that will be used on the home screen of the iOS device, we cannot use the manifest as an Android, for example, but we have to provide a further entry with the value Apple Touch icon in the index.html, so a link tag. So this is one of the limitations still existing on the iOS environment. Another file that is created automatically for us is the NGSW, that means Angular Service Worker configuration file. This is a JSON file that allows us to define which assets we wanted to cache. By default, Angular creates an array object called asset groups. In here we have two objects. The first one with name app, we can see that there's an install mode prefetch. Let me zoom it. So this install mode prefetch means that these files that we can list here under will be fetched, so downloaded by the service worker while the service worker is installing. This is because we wanted to fetch from the network these files, these assets that constitute our core, our shell application. And we want to be sure that when the service worker is installed, these files will be correctly available in the cache, so that we can provide already the user with these files when the user accesses it without a network connection. For example, these files can be for a branded offline page, for example. And this means indeed prefetch. So fetch these resources while the service worker is installing. It's important though that we don't put too many files here or too big files here, because if this fetching phase fails, so if the service worker cannot download at least or cannot download all these files, then the installation process will be aborted. So we won't have any service worker installed on our side. Of course, the service worker will try to be installed the next time we access the page or when we reload the page. But we have to keep that in mind. The second group, with name assets by default, uses, in this case, an install mode lazy. Lazy means that we wanted to cache those assets, but only after they have been requested at least once. In this case, we can see we target all the content of the assets folder, for example, some icons that are not so critical for us, and some font icons. In this case, we can also provide a further property, update mode, with value, in this case, prefetch. Update mode tells how or which is the strategy that should be used when the service worker detects that there is a newer version of these assets in the on the server. With prefetch means that as soon as the service worker detects a newer version, then immediately downloads it. We could have used a value lazy in this case. In that case, then the already cached assets would be updated only after they have been requested again another time. So not eagerly and not immediately. So those objects and this file is created exactly like this by default when we execute that command. But Angular allows us to do more and to achieve a more advanced capability or functionality. For this, we can create an object with name data groups. These allow us to implement this cache first or network first strategy that in the Angular context are respectively called performance and freshness. With that, we can cache HTTP calls that will be stored locally. In this case, let's see the first one. We give the name of the cache, jokes cache, and I target this URL that provides that jokes, just for the sake of a test. Then we want a strategy performance, meaning that we want a very, very fast response because we implemented the cache first strategy. We wanted to retain maximum of 5 entries in the cache and for at least, at most 15 minutes. After that, the cache will be pruned. On the other side, if we want to implement the strategy freshness, so very, very up-to-date values, we can implement the caching strategy freshness in this way. So we just target other URL. In this case, is an URL that provides random images of cats. And then again, we can provide how many, a value for how many items do we want to keep in the cache, for how long with the max age property. And then here important, we can define a timeout. Here 5 seconds. Means that if I request if I execute a request on this URL and there is a timeout of 5 seconds, then Angular will, or the service worker will try to provide the requested response targeting this GET request from the cache, of course, if available. But that's it. So with these few lines of code, so actually just the data group would be the line of code that we have to enter, we can have already a progressive web app that not only is capable of caching static assets that are here on the upper part for us by default created, but also dynamic HTTP calls. And this, of course, has to be done by us. Let's see now the demo that runs using this code. We cannot use NGSW because NGSW doesn't work with service worker. For this, I use the Chrome extension web server, and I made an ng build prod, so a production build, and I serve the code from the distribution folder. You can use otherwise in the npm HTTP server or any HTTP server of your choice. So this is the application that is using the code. We can see on the left side in this card, there is the joke that comes from the website and is using performance caching strategy. So every 15 minutes it changes. So probably when I will refresh, the joke will change because I was having that this page already open. And on the right side, we can see the cat photo. And this uses a freshness caching strategy. So every time will be a new one. If we want to investigate the details of service worker, we can do thanks to the application tab in the Chrome DevTools and using the service worker menu. We can see that for my current URL, in this case I'm serving in from localhost, we have the service worker then is activated and running. We can also access the manifest tab to see whether there are any problems or just listing all the manifest values from our manifest file. But more important is checking the network tab. Let's see now I refresh. Okay, the first time we can see the joke changed. But now if I refresh it again, the joke remained the same because it replaced the previous old version from the cache. And we can see indeed that the endpoint, let me zoom a bit. The endpoint thejoke.com comes from the service worker, while the cats API goes over the network. Now, if I go offline, so let's say I lose my connection, or I am in an area where I don't have any internet connection. Still, if I refresh the page, I can not only provide both values, so both endpoints and all my contact. And we can also see that response is almost immediate because the service worker detects that we are offline, and there is a fallback of the CATS API. So also the CATS API is served from the service worker from the cache. So we can, even offline, we can very easily provide content from our website. Now, if I switch online again and I refresh, we can see once again the joke remains the same, and here we have a brand new image of the cats. Let's go back again to the code, because I want to tell you about a very important file. Let's open the distribution folder. Is the ngserviceworker.json. This is a file that keeps an hash table with all the cached resources or assets. This is important because this hash table is used by the service worker to detect whether on the server there is a newer version of that or not. So that said, if we go back now to our website, we can see that here also there is this ng service worker JSON file that is downloaded, and indeed we can see here all the hash table files, and this is downloaded every time. Now let's see, we did a mistake. We deployed a buggy version and we want to wipe all the users cache. To do that, we can delete this file and then deploy a version with this file. When we go in the application and we go in the cache storage, we can see here all the assets that have been cached. So the cat's image or the endpoints and so on. So everything that our service worker cached, it's here. So now what I would expect is that I delete this file from my resource. Yes. And let's imagine I deploy it. Since I'm using this web server extension, Chrome extension, I just have to refresh the page or just stop it, restart it. And now if I refresh the page, what I would expect is that all these cache items will be wiped out. So I refresh the page and the service worker tries to download that item, and exactly. Now we can see that this cache has been wiped out. If we go on the network, we can see that here indeed our service worker JSON file or NGSW was attempted to be downloaded, but it was not found. And because of this, then as a safety measure, the service worker gets uninstalled, gets deleted. We can see here that we have deleted as a status, and all the content of the cache is wiped out. So this is a safety measure that is good that you keep in mind in case you might need to wipe all the users' cache when they access your application. And this was a very simple demo to show though how powerful is Angular in providing these tools and making it very easy to implement the progressive web apps from nothing. Oh, that's it. Let's go back to our presentation. So we showed that we can cache get requests, but unfortunately the service worker uses the cache API that currently does not allow to cache anything else than get calls. So how we can do in case we need also to cache eventually also post and put calls. Get calls are probably covering already the 99% of cases when we want to provide the data from our website offline. But in some other cases, we might want to provide an even better experience for our users that can even change the local data and then having it synchronized and sent it offline while online again. So there are different solutions. One solution is implementing a custom project, a custom logic that needs to implement IndexedDB, for example, so that we can detect when the user is offline and then cache in these or save in this IndexedDB all the post and put calls. And then when the user is online again, our application will go over all the records saved in this local IndexedDB and trigger one by one in order all of them. Of course, it's not very complex, but there is some logic to do. But again, luckily for us, there are tools that can help us going into this direction. And one of these tools is Cloud Firestore, belonging to the Firebase platform. It's owned by Google. Cloud Firestore is a NoSQL database that allows for native apps, but also for web development, allows offline persistence. That means that once we install, of course, download the library, install it, and then we instantiate it, we can call the enable persistence method. And this is all what we need. After that, Cloud Firestore will cache every single document received from the backend and make it available for offline access. From that moment, we can not only read, but also edit local documents. And then when the users are online again, Cloud Firestore will detect that there are some local pending changes, and we will synchronize automatically these changes for us. And this is completely transparent for us and for the user. The cache threshold is by default 40 megabyte. We can though define a lower amount of data that is saved locally or even increase it. As soon as then the user reach the limit that we defined, Cloud Firestore will automatically for us prune the oldest documents. And that's it. So let's see now another demo, showing how indeed with the Cloud Firestore and with Angular, with the Progressive Web Apps capabilities, how we can provide an application to the users that is completely seamless so that it works identically even online and offline. So let me open one browser, we don't need it. So I will open one browser and then let me mirror my, I lost the connection, good. Sorry for that. So I have to connect it again. So what I want to show is on the left side is the Progressive Web App application that is stored on Cloud Firestore, Firebase, and is using Cloud Firestore as a NoSQL database. And on the right side, what I want to do, hopefully it works, I want to share, yes, continue. I want to share the, so mirror my phone, Android phone, when the same application is installed. And of course, since we are live and we are live coding, this doesn't work. Let's hope, no. Let me do it again then. Yes. Okay. Let's hope you can see it. Looks better. Good. Looks good. Perfect. Okay, we are good. So this is on the right side is my phone. And we can see here just 4 icons. And these icons actually are 4 Progressive Web Apps that I implemented. We will access the same application. So it's an application that I implemented for myself. It collects all the places that I liked, so restaurants or bar that I visited while traveling, so that I can give my own rate and then suggest it to my friends, or actually suggest to not visit if it was not good. If we look now at the emulator, or in the case the mirror of my phone on the right side, we can see that if I open the all the open apps, we can see that my progressive web app is listed as it would be a native app. It's not listed as a part of the Chrome tabs. It's just really independent. And this is thanks to the displayed mode standalone that we saw before. So we can open one of these documents. Okay, here he has offline since my last demo. And if I save it, we can see that this change is automatically propagated on the right side. This is another very cool feature of Cloud File Store. It's called three-way binding, meaning that when we change something locally on one client, so here on the browser, let's say is a client A, then and save it, then those changes will be propagated automatically through WebSocket to the all other clients that are connected to the same server. And we can see here the name has been updated. So this is also a very nice aspect. But let's see now the really cool functionality of this offline persistence. So I switch now on offline mode, and I covered the case that now I'm traveling, and with my phone I'm completely offline. Of course, I can refresh my page. This is an offline application, and I can get all my data, so nothing new now. I can access one previously visited document, and I still have all the data. I can change here, so change, for example, change. I save it, and now if I go on the home, we can see that I have under the title change written, but of course on the left side my the application that is accessed through the browser doesn't have the name changed, because with the phone I'm offline, so I'm detached from the network, so I changes things that are only local. I can even open another document. Let's open this pizza place, change something for the sake of the test, save it, and then again go over the home, and we can see that again another document, the title has been changed, like this one, and the others documents just are available, but of course untouched. Left side, we don't have anything changed, because this is with the browser is the live and connected version. But now, if I switch off my offline mode, so my airplane mode, what Cloud File Store will do, it will detect that there are some changes, and then will push on the left side. Yeah, indeed, now we can see that the changes that we did on the right side are now propagated through the sockets, so web sockets are propagated to all the other online clients that will receive automatically these changes. So with these technologies, we can really build applications like the one I created that are completely seamless. So the user actually use our application, but he or she won't have any clue whether he's offline or she's online, because the application will simply work no matter of the network status. So this is a really powerful technology and powerful possibilities that we can introduce in our applications. So questions that many people then do after I present all the capabilities of progressive web apps. Will progressive web apps take over native apps? Well, I would say not over, or at least, of course, not completely. This is because, as we saw before, many features are still not fully supported by Apple. So if we want to target Apple and all iOS devices, then we have to take this into account. For example, web notifications are still not supported by iOS. Another aspect is that the progressive web app can do only what the web apps can do. So for example, we cannot have immediate access to the contact list of a user device. Even though there are some beta libraries, for example, from Google, there is a contact picker API that is allowing this. So there is still the will to fill and to fill these gaps that are still between progressive web apps and native apps. And lastly, native apps have in general a better performance as they are tied into the underlying operating system, while progressive web apps are provided or work through the browser. Just to conclude, some more progressive web app resources. So I hope I could stimulate some interest in learning more and go more deep in progressive web apps. And these are some very interesting websites. The first two, so PWA Rocks and Upscope, provide a kind of a gallery of existing progressive web apps that you can use in order to get inspired and see what is possible to achieve with the progressive web apps. PWA Stats is a website collecting all successful stories that resume how different companies benefit from adopting progressive web apps. And the last two are concerning more kind of educative content. So Stack Overflow PWA website provides the top Stack Overflow questions about service worker or progressive web apps. And the last, what the PWA can do .today website shows all the functionalities and features that are possible through progressive web apps. That said, I concluded my presentation. Thank you very much for your attention. I hope you enjoyed. And if you want to get regular content about progressive web apps or the modern web API in general, please follow me on Twitter. Here is the handle, or read my articles that I publish a bit less frequently on Dev Portal. But that's it. Thank you very much for your attention. I finished my presentation. And I can give back word to Wayne now.
All right. Thank you very much, Francesco. Really appreciate that amazing session.
Thank you.
You really went in depth. You really explained the whatever happens behind the scenes on PWA, and we're really grateful for that. In just like 5 minutes, I'd like to open the floor to any burning question anyone would like to ask with regards to PWAs or just web apps or Angular apps in general. If anyone has any question.
Not a question really, but the GitHub handle.
Yeah, I will. Let me share it again, so at least you have my details, and I can show that again. But I will.
Yeah, you can share, I think, it with me, and then I'll also put it with all the information on our Twitter handle too.
Yeah, that's better.
So here are my, let's say, coordinates or Twitter handle. I will make a post with the slides and the repo on Twitter. Or in any case, I can, let me skip if you want, because then it's hard to copy. So probably that's the easiest. Otherwise, the first.
Yeah, you can just also share it with me, and then I'll just share it to the whole community through an email or through a post.
Okay, then I will do like this. It's probably the easiest. Thank you.
Yeah. Anyone else who has a question?
Not a question. I just want to thank you for taking your time to explain more about PWA. I've always wanted to hear more about it. Thanks.
Thank you very much, Monica.
Anyone else? Okay, so let me just ask. For me, I think my question would be, when should one decide to go the PWA way? Like, is it something that we should do on the onset of creating application, or we should wait to, like, I don't know, like till sometime when you feel like, oh, people actually want to use it they want to access the sites using their phones? Like, when do you get to decide when to go the PWA way?
Yeah, I think when we think about PWA application, doesn't mean that it has to be all at once. We can go with with the process that is a step by step, and many web apps can still benefit from caching strategies and from service worker in order to provide a much quicker response. So even though we don't want to provide offline first approach, for example, we can still use caching strategies to make the responses much faster. Or, for example, to caching assets that don't change much or often. For example, if we have an application like a blog that has avatars or icons for our users, we can let them cache those on their site. So the next time they access our blog website, this will be much faster because all these assets don't have to be downloaded every time, can be provided straight from the local cache. Plus, we can even then provide offline data eventually if needed. When going, the bigger question probably is whether we want to implement a PWA or whether it would be better to go over native. That depends on the domain. There is not really a silver bullet solution for that. Of course, we can even implement kind of hybrid approaches or solution. So we can create, for example, a TWA or trusted web application. And this actually is very powerful because allow us to embed into this APK Android package our progressive web app and have this published on the Play Store so that we can eventually reach our clients not only via browser, so via indexing or CEO, but also thanks to the Play Store. And then the other benefit of having a hybrid application in this case would be that we can have the benefit or the logic of a progressive web app, but we can use also some native apps API, for example, to access the hardware of the device. But probably if for us, for example, the Apple devices or the users that have Apple devices, it's very important, then probably we should or we need a native app. Because in that case, we have quite some drawbacks with progressive web apps. But again, if we don't need web notifications or if we don't need all the spectrum of functionalities provided by progressive web apps, but only, for example, the caching functionalities, then in that case, it works also for iOS. Therefore, I would say the efforts to go and implement a progressive web app compared to a native app is extremely smaller, because we can take a normal an existing web application and start progressively enhance and bring in more and more or step by step more and more progressive web app functionalities. But the web application is already existing. We can use our web developers to do that and to enhance it. That we don't need a dedicated native app developers, iOS or Android, to, of course, implement a brand new native app. So the efforts, time, and cost to implement a progressive app would be much smaller. But then, of course, as I said before, if the requirements play against the limits or the current limits of progressive web apps, then native apps are still the best choice. I hope with that to...
All right.
Yeah.
Yeah. It really answered the question. Yeah. So yeah, thank you once again, Francesco, for taking your time to check our attendees through this whole session.
Yeah.
And would like to say a big thank you once again for taking that initiative of going even in depth and explaining what service workers are all about, caching is all about. And I hope that some of these members have actually gained interest. I'm really interested in PWAs. Like, coincidentally, I'm giving a session on PWA this weekend for a community here in Kenya. And this has also enriched my knowledge about PWAs that I did not know about. And without much further ado, I'd like to give the meeting to a close. For those who have just joined us, please make sure to follow Francesco on Twitter in case you need further information on whatever he's been teaching about or what he's been talking about all through. Also look at his works. I will share with all of you the links for the slides, the GitHub repo, and any other resources that he may share with us. I will also share it with you. And also we'll put in this recording on YouTube where you can just access it anytime you want. And yeah, I'd like to say thank you, our attendees, for attending this session. And I hope you've learned something. So please, whatever you learn, whatever you have in mind, please share it with us on Twitter, tag us, tag Francesco to just compliment what he has done for us. And yeah, hope to see you guys next week around the same time. And yeah, thank you guys. Have a good night.
Thank you very much. Bye, guys. Thank you again.
Bye, Francesco.
Bye.